Hi, this chapter is chapter 4.4 of Elementary and Intermediate Algebra. In this video, I'll be going over more solving one-variable linear equations. So solving equations. In order to solve an equation, the variable in question has to be isolated by itself. So in order to do this, we have to combine like terms and use the multiplication and addition properties of equality to make sure the variable is by itself. So let's solve the equation 5x plus 6 is equal to negative 2x minus 8. In order to solve the equation, we have to try to make sure we get the x on one side and all the other stuff on the other side, and we have to make sure that the x has no constant multiplied by it. Alright, so this is pretty simple. Let's start off by getting the 6 to this side. So the easiest way to get the 6 to the other side is to subtract 6 from both sides. So 5x plus 6 minus 6 is equal to 2x minus 8 minus 6. So what's 5x plus 6 minus 6? Just 5x. So these 6's go away. So now we have 2x, negative 2x minus 8 minus 6 is just equal to negative 2x minus 14 is equal to 5x. Alright, good. So this 5x is on this side by itself, but this negative 2x is still on the right. So you want to get this negative 2x to the left side. So what we can do is we can add 2x to both sides. So 5x plus 2x is equal to negative 2x plus 2x minus 14. So negative 2x plus 2x is just 0. So these just go away. So we just leave negative 14 on this side. And what we get 7x on this side. So 7x is equal to negative 14. Then we just divide both sides by 7 to try to get this x by itself. And we get x is equal to negative 2. It's not too bad. It's pretty simple. But there are going to be more complicated problems like this later on. So we can use the distributive property of multiplication to break up parentheses. So let's solve 4 times 2x plus 3 minus 6, and that's equal to 5 times 2x plus 4 minus 8. So let's break up this parentheses right here. So using the distributive property, we get 8x plus 12 minus 6 is equal to 5 times 2x plus 4, which is 10x plus 20 minus 8. So we can just do a little bit of addition here. So 8x plus 12 minus 6. We can just use the associative property to solve this first. So 8x minus 6 is equal to 10x. Using the associative property again, we can add these two. So this is 10x plus 12. Okay, so now let's get the 6 to the other side. So we add 6 to both sides. So 8x minus 6 plus 6. These just cancel out. This is equal to 10x plus 12 plus 6. So this is 8x is equal to 10x plus 18. Now we want to get this 10x to the other side. So we subtract both sides by 10x. So 8x minus 10x is equal to 18. So negative 2x is equal to 18. So now divide both sides by negative 2 to isolate the x. So you get x is equal to negative 9. This one's a lot trickier because we have to do a lot more steps, but you'll get the hang of it. So when solving equations with fractions, we want to try to get rid of the fractions by turning all of the numbers into integers. And the easiest way to do this is to multiply by the LCD, or the least common denominator. So we can just list out the multiples of 2. So we get 2, 4, 6, 8, 10, 12. We can list out the multiples of 5, 5, 10, 15. And we'll find that the smallest one they have in common is 10. So what we can do is we can multiply both sides by 10. So we have 10 times 2/5 x plus 3/2 is equal to 10 times 4/5 x plus 1/2. This is pretty, alright, so we can use the distributive property to break up these parentheses. So we have 20 divided by 5x plus plus 15 is equal to 40 over 5 x plus 5. Alright, so we want to isolate our variable, so let's get the 5 over to this side and a 20 over 5x to this side. So if we subtract both sides by 5, so let's minus 5 to both sides, we'll get that 20 over 5x plus 15 minus 5 is equal to 40 over 5x. So 15, we can use the associative property to solve this. So what's 15 minus 5? This is just 10. So 20 over 5x plus 10 is equal to 40 over 5x. So we can just subtract 20 over 5 from both sides. 20 over 5x. So 10 is equal to 40 over 5x minus 20 over 5x, which is just 20 over 5x. So 10 is equal to 20 over 5x. You can just multiply, 20 divided by 5 is equal to 4. So this is just 4x. So 10 is equal to 4x. Just divide both sides by 4, and we'll get 10 over 4 is equal to x. So that's our solution. We can simplify 10 over 2 by dividing both sides, top and bottom, by 2, and we'll get that the real answer is x equals 5 over 2. So the real answer is x equals 5 over 2. Yeah. So this one is fairly complicated, but it's the same idea as the previous ones. We just want to break up everything and try to get x to one side and the number on the other side. So decimals look a lot more complicated, but they're easy to solve if you just treat them like any other ordinary number. So 5.2x plus 6 is equal to 2.2x plus 9. Alright, so let's get the 6 to the right, and let's get the 2.2 to the left. So we can subtract both sides by 6. Okay, so what's plus 6 minus 6 is just equal to 0. And what's plus 9 minus 6? This is just equal to 3. So we have 5.2x is equal to 2.2x plus 3. So now let's get this 2.2x to the other side. So we can subtract both sides by 2.2x. So 5.2x minus 2.2x is equal to 2.2x minus 2.2x plus 3. So the 2.2x's cancel, and this turns into 5. What's 5.2 minus 2.2? That's just 3. So we have 3x is equal to 3. So if we divide both sides by 3, so 3x over 3 is equal to 3 over 3. We get these cancel out, so this will just turn to x equals 1. So we can also use equations to model situations, and in order to do this we have to understand how slope-intercept equations, how we can use that to model situations. So let's say there are 1,000 people in a town in 2014, and each year the population increases by 200 people. So let n be the number of people in the town, and x be the number of years after 2014. The question says to create a model of the situation and determine when there will be 2,200 people in town. So when we create an equation, we want the dependent variable on one side, so that's n, the number of people, and we want the independent variable on the other side, so x. So our y-intercept is going to be how much the population, how big the population is at the initial year, and there's 1,000 people initially, so that's our y-intercept right here. And our population increases by 200 people every year. So we know that the slope, or how much it increases by every year, is 200. Alright, so that's actually our equation. It's very simple. And it says determine when there will be 2,200 people. So 2,200 people is our dependent variable. We can just plug that in. So 2,200 is equal to 200x plus 1,000. So our first step is going to be trying to get the variable by itself, and we can subtract 1,000 from both sides. So 22. So this minus 1,000 as well. So we have 1,200 is equal to 200x. And we divide both sides by 200. And we get x is equal to 6. So that means after 6 years, the population will be 2,200. So we add the 6 to 2014, and that so basically means that in 2020, we will have 2,200 people in town. We can also solve equations by graphing both sides of the equation onto a graph and seeing where they intersect. So if you have an equation, let's say 3 over 3 halves x plus 2 is equal to 5 halves x plus 1. So I graphed both of these onto a little graph here, and as you can see, they both intersect at x equals 1. So by seeing where they intersect, we can understand what the solution is. Basically, it means that since both of them intersect at x equals 1, the answer is x equals 1. This looks pretty easy, but it usually takes the longest because you have to put it onto a graph. So once you get really good at solving equations by hand, you really shouldn't have to graph them anymore. So there are 3 types of equations you should know. And a conditional equation is an equation with a specific set of solutions. So an equation is only true conditionally. For example, x plus 1 equals 9. In this case, there's only one solution, which is 8. It's only true when x equals 8. If x is equal to any other number, the equation is not true. A false equation is an equation with no answers, or it's never true. So example, x equals x plus 1. An identity equation is an equation with a solution set of all real numbers, or x is equal to x. And as you can tell, any number is equal to itself, so the solution set is all real numbers. That's it for this video. Thank you for watching, and I hope you learned something from this video.